Cool. We have an agenda today, right?
Yes.
Yeah. Wow.
And we're all there, so let's go.
So when I saw the agenda, just something to add. I think a lot of things we're talking about are assuming that we have a clear definition of support. And I'm wondering if we all have the same definition in our minds.
Good question.
Yeah. Just to add.
Do we want to spend time on the definition of support? I don't know.
Yeah, I don't. How do you guys feel about it?
I'm happy leaving that understanding vague until it comes and turns into a problem, I guess.
Okay, good for me. Yeah.
Yeah, same, to be honest.
Stephen, you're talking. Stephen, you're
yeah, I was muted. Sorry. In a way, yeah, it's vague because maybe we forgot about it, but I'm fairly certain we talked about it in the past and we defined it as a fairly vague thing to be specialized by later, more specialized forms of support. I think we said anything that, to one degree or another, gives extra reason to believe. I think that's the definition we did settle on, but I might be mistaken. That's why we need more documentation.
Yeah, just be aware, and once that might be an issue, we should get into it.
Let me rephrase this. Do you see a potential roadblock in the misalignment of that definition?
Once we're talking about mapping and logical relations, like once we map multiple supports to something else like mutual exclusion, I think it's very important to have a precise definition of what it is, to see if it holds, if this mapping holds all the time.
right. I think it is an important discussion. I don't want to have the discussion because how many times have I seen the entire meeting become that discussion that's not on the agenda? So
fair.
I know it'll come up, and I'm okay with talking about it. But yeah,
you have an agenda. Let's do it.
Yep.
Right. So the first part of the agenda was like we were that close, I think, to finishing our discussion on the compound claims as claims. And I say we were that close because actually in the end, I guess Marc-Antoine had convinced me, and then you said you were making a 180, so we'll see where that goes. But like to maybe try to summarize, I think we were at the point, the question was in a layer 2 advanced structure, right? If we imagine a compound claim or compound premise, a compound structure that essentially represents a set of premises with some rules, some formal rule of how they relate to each other, whether it be mathematical or logical or something else. Is there a reason to have it be a claim? In other words, to have it be supported or opposed
as a whole?
As a whole, right? Right. Is there any reason for that, or is the support or oppose always going to be in the context of a conclusion? In other words, you're actually supporting or opposing its use to prove a conclusion, right? Yeah. And I had been against that all along. The thing that convinced me was the claim. It was a simple and claim. That was, now I can't remember it, but I know it's something like Marc-Antoine and I are in the CDL, right? Well, is that a good? No, it was important that it was the missile launch example, and that was important because that had external consequences. You could observe externally implications of that conclusion or that claim, and oppose it without opposing the specific elements of it. So it was, Ann and Bob press the button. And I take the simpler form because all the knots got it a little confusing and the XORs and all that. But you can just say, Ann and Bob press the button to fire the missile, right?
When we don't know and don't care who it is exactly.
Right. And you say, you oppose it by saying, essentially, the missile didn't fire. And if they had pressed the button, the missile would have fired. Okay. I think that's both a valid claim that they both pressed the button as a claim. I think it's a valid opposition without talking about formula. You're not saying the and is wrong. You're saying that the claim itself is wrong. And that discussion could be, well, the mechanism must have failed or something else. There could be other reasons. But the interesting thing is, if you look at the structure, and maybe we have to go back to diagrams, but I think it's simple enough. Maybe we can just kind of picture it in our heads, right? That Anne and Bob press the button. Now, if you can't oppose the claim as a whole, then you have this claim that the missile didn't fire. It's actually a compound claim of its own. The missile didn't fire, and the missile would have to have fired if they both pressed the button. How do you do that without opposing directly the compound claim? You would have to do it by making that other compound claim of the missile didn't fire, and it would have had to have fired if they both pressed the button, and use it as an argument against both and press the button and Bob press the button. In other words, you've got this observable result that argues against that. And the only way to use it if you can't oppose the top level claim is you have to oppose each individual outcome. And there's no way to know which one of the two it supports correctly, right? And I think that's even more awkward than just opposing the compound result. Does that make sense to people?
What I'm hearing is it's important to be able to oppose a compound independently of its atoms. Agree totally. That's not what I did a 180 on.
No, you didn't. Yeah, okay, good. Yeah, that's what I did do a 180 on. Yeah.
Okay, and I was always for it because once you can formulate it with natural language, and that's something people say, of course, it should be possible to oppose it.
As a compound, yeah.
As a compound.
And Stephen's saying we can oppose it even if it's not formalized, then I agree with that as well.
Right. I mean, the other approach, the approach I was thinking of is you have the compound formula and the two things, and you use that to support an actual conclusion, which is that they both press the button. So you separate the two things, right?
Separate logic from.
No.
If you try to define which two things you separate, I would say it is logic from the claims.
Right. Yeah, but stop. Let's not talk about layers here. We're not talking about layers. The question is, in the layer 2, is there any reason to have the logic? Yeah.
Now you're mentioning layers yourself. I didn't mention layers. I just said, semantically speaking, you're separating logic, like A and B necessarily C follows from just the claims, like regardless of which layer.
Right, but and that also gets into the follow-up discussion, which is how do you monoliths, and there actually is the follow-up that I do want to get into.
Yeah.
Which
Before
is
we do
how
that,
in the base layer.
Tal wanted to say something.
I want to see that I'm following up. If I understand correctly, if you have a compound claim and it's usually professing that something will happen, the missile will be launched or was launched or this.
It could be in the past.
Yeah.
It could be in the past.
It is a description of observation. Okay, future observation, past observation. Okay, we saw that the missile was launched, or we saw that the missile was not launched, right? So if I understand correctly, and if the missile was not launched, or if something else was not going according to the compound claim, the whole compound claim is falsified.
Validated. Yeah.
But it doesn't mean that the atomic claims, which constructed, were falsified. You have to check each one of them individually. Maybe but there is a problem with the missiles. Maybe it's enough just one person to press and the missile will be launched, etc., etc. So this is the rule I'm seeing. Is it what you meant?
You're understanding the situation that we're trying to model. The specifics, I don't know if you are understanding or not, because I think it is really detailed into how we were showing the model. So I'm not sure.
I can follow up. I don't want to disturb.
Let me speak generally instead of specifically. The question is, at some point, Tim was saying it makes no sense to agree. Let's say the compound claim is a and, right? And it makes no sense.
The compound claim is
a and, A and B.
A and B. Okay, yeah.
Okay. So it makes no sense to agree with the atoms and not agree with the compound. Hence, he was saying, let's not even allow people to disagree with the compound without going to disagreeing with one of the atoms. Let's force people to specify. And then I was arguing there's a lot of cases where we don't know about atoms, but we still have an opinion about the compound in its own right, even if it's not part of, even if it's not the premise of another support. It's just we can disagree with the compound without knowing the status of the atoms. And I think we're now converging on that. And there's the whole, anyway, there's more to it than that, especially do the atoms have a kind of support oppose structure, but inherent in the compound? I don't think so. That makes sense when the compound is used as a premise, not as a conclusion. That's a whole other story. We can go deeper into that. But that's the basic thing we're trying to do.
Okay.
Does it make sense to have an opinion about the compound?
So what we're trying to understand between the compound and the atoms, what is
the compound a claim in its own right? That is it something that can be supported or opposed in its own right without supporting or opposing the atoms?
Yeah, for me, I'm a Popperian, so for me, if you had a claim, I mean, it was falsified, it was falsified. It doesn't matter if it's compound from little atoms, big atoms, molecules, doesn't matter. You claim something, and let's check it.
For you, the compound is a claim, qualifies as a claim. Yeah. Like me.
Right. Well, I think the actual essence of the disagreement, or possibly confusion, is an equation is an equation.
Yeah.
An equation can't be wrong unless you're disagreeing with mathematics itself, right? And when your claim is, and we go back to the force example, if the claim is that under the equation, force equals mass times velocity. If I have a mass of 5 kilograms and a velocity of 5 meters per second, the force is 25 newtons.
But it's exactly the same situation, right? I can say,
but it's not.
It is,
because
it is.
No. And here's where it's a problem. Because I'm saying force, the claim here, and this is a distinction I wanted to get to. The only time it makes sense to embed, shall we say, the logic inside the claim is when they are one and the same. So Ann and Bob press the button, right? Is just Ann and Bob press the button. There's no other, you prove Ann press a button, or you prove Ann and Bob press the button, you proved Ann and Bob press a button, you prove Ann press a button, and separately you prove Bob press the button. There's no way to disagree if you have conclusively proved both of them, correct? Right.
Yeah.
If I have like an actual video of Ann pressing the button,
I agree with that.
Right.
I agree
okay.
with that.
And yet you have a situation where you can still disagree that they both press the button for outside reasons. If, you know, what do you do if you conclusively show that they both press the button and yet somebody disagrees outside? you have a conflict that has to be resolved that you can resolve through external things like, oh, the mechanism must have failed, right? In other words, your proof that they didn't.
Yeah,
right,
but
your proof.
You're confusing with the conclusion of the next step. Sorry, the Ann and Bob press the button is a claim in its own right, we said. So I can disagree with that. And the reason for disagreeing with that is it's embedding in the, oh, the missile didn't launch. Okay. Now, if you prove to me that Anne didn't press the button, for example, then Anne and Bob, then if I still believe if I believe you and believe Anne and Bob pressed the button, I'm in trouble with logic. But the next step only is when I say, oh, I believe Anne and Bob pressed the button, and then the missile didn't launch, then I can have defeaters like the mechanism was broken.
Right.
But that's at the next step. But I'm interested only in the first step right now.
And what I'm saying here is I can't visualize a situation where, because if it's a mathematical equation, the claim is force.
No, but let me draw the parallel.
Yeah.
For me, it's exactly the same thing, in the sense that I agree that once you've agreed on the status of Anne press the button and Bob press the button, the status, you're kind of tight about the status of A and B press the button because it's embedded. That's fine. But what I'm saying is it's possible for me to disagree with Anne and Bob press the button without having knowledge or opinion, or while being perfectly agnostic about Anne press the button and Bob press the button, right? I don't know. I just know that they didn't both do it, but maybe one did it, maybe neither, maybe all I know is they didn't both do it. And I can be clear about the result while being unclear about the premise. Exactly the same thing. If F equals MA and I say, well, F isn't, you tell me M is 5, A is 5, so F is 25, F is 25. I cannot agree with F if F is 5, A is 5, and A is 20, F is 25, and the application and the equation is a proper modeling of the situation. I cannot agree with all of those. That's inconsistent. But what I can perfectly do is say, yes, this is the right modeling. No, the force is 30, but I don't know which one of the other two are wrong. I'm agnostic about that. I know the force is 30, it's not 25. I know that's the right equation. So one of the inputs is wrong. I don't know which one, and I cannot know in this situation. I just know that one of them has to be wrong.
Here's the fundamental question. What is the claim? What is the claim?
The claim
if the claim is the force is 25 newtons in a certain situation, right? We're talking, it has to be disambiguate. You're talking about a certain situation, right? Then I would say that embedding the function into that is wrong, because there will be dispute about which function. So that's not the claim. The claim with the function embedded is specifically force as defined by the function F equals mv is 25 newtons.
Okay, that's where we're progressing here, I feel. For me, you are correct that we can divide this into claims. And it's true that for me, force is 25 was not the premise of something else, but it's a claim in its own right. And it can be supported by the F equal MA applied to this and that and that. And so it's true that the disagreement is not with this is the result of the function application. It could be, I mean, if there were Intel inside, or I say, okay, let's actually use form of calculation that preserves uncertainty, or whatever. You have the wrong precision on your things, so there could be all ways of disagreeing. But let's assume none of that. I am bound by Those premises lead that, and that supports the forces 25 claim. But it's so tight in the sense that if I disagree with the force equal 25 claim, which I agree is a distinct claim, it means that I have to either disagree that this is the right formula, but let's say I'm agreeing with that, and or disagreeing with one of the other inputs, and let's say I don't know which. And I think that's a valid move, is all I'm saying, really. But I understand that you
But then-
want to just...
But that's why in that case I extract the formula into this compound premise and use it to support the 25 thing, right? Because you want to be able to disagree on the formula itself, and you do that, or one way to do that would be disagreeing with the support.
But
Agree with using that as a support.
But do you see what I'm saying about this is exactly the same situation as Anne and Bob press the button. Anne and Bob press the button is like 25 newtons. And the Anne and Bob is equivalent to the formalized decomposition in Anne and Bob is an end of the Anne press the button atom and the Bob press the button atom. And this one is kind of uncontrovertible. It's a decomposition. Now, in this case, I would argue it's an interpretation of the informal claim. And yeah, I guess that's not the same as saying that as a relation between the formula and the conclusion number. So maybe there is a difference.
I have to say I didn't follow Tim's argument. I was trying, and I thought I understand what Mark Anthony was saying, but can you try to simplify what you are saying?
Let me see if I can. I don't know if I have the diagram, because that might help.
It would be worth doing those two diagrams side by side.
Yeah. I think it will clarify things.
It reminds me of the situation when I introduced the equations a bit.
Well, this is exactly what this is about.
Yeah, this is where it came from, this discussion. Oh, wait, there's a functional claim example. Maybe that's it.
And it will be actually a good time to, you know what, let me get it out. This is the CDL loading. Yeah, let me share screen. I have it not too far. I don't know if that's the one we wanted, but it's there.
That's the one. I was just opening it. Yeah, that's the one.
Okay, good. You know what? I think I'll start from scratch. Can I just, yeah.
Well, maybe if you go over to, there was an F equals MA. If you go over there, we don't have to look at the whole, on the left, all the way on the left. We don't have to look at the whole thing. But, okay, yeah. The question here is, say somebody wants to say that the force of something is 25 newtons, right? Say that's the claim. It's essentially the force here, or the force required, or whatever, is 25 newtons, right? So that's a claim. And you can oppose it by things like, I measured it and it's 28 or something like that.
Well,
but you could also...
We had 98. Let's actually go with the text on the here. It's
okay.
98.
It will be simpler, yeah, if we can follow that.
The velocity equals
the velocity.
Acceleration times time.
Okay. So somebody could somebody could oppose that by saying, I just measured their velocity and it wasn't that, right?
Yeah.
Somebody could also support or oppose it by saying, well, according to this physics equation, it should be this, right? So you can try to prove it through a physics law, right, equation. Mm-hmm. And the reason for modeling this, extracting it into a model, would be that you would have the equation supporting it, and then you could just debate. You essentially break the debate up into three isolated points. One is what is the acceleration? You have that debate. And once you've figured out that debate, how long, what is the time? And once you've solved that question, the result follows naturally, right? You don't have to have a debate about what is acceleration times time. That's math, right?
Yeah, but and there's an implicit claim here that this is the right formula to apply.
Well, except that so then you can use the design I was discussing at the very beginning before I agreed it could be embedded in a claim, is that essentially you use that to prove the conclusion of what is their velocity. And in any support, people can disagree with the use of that support. And so they could say, for example, you're using the wrong equation. Which means you could propose an alternate equation. You can try to support it using some of the same facts, but in fact use a different equation that includes air resistance, for example.
But this is something I'm trying to understand. So basically I have observation, right? I'm saying that the speed is different from that, or follows F1 or F2, right?
Yeah.
So if it follows F2, I'll say, okay, it was corroborated. Okay, F2 was corroborated, and if it doesn't go according to F2, it was rejected, or the claim itself was rejected. Okay, maybe there is something.
Well, if you
what you're saying is correct.
If you're unable to measure it, for example.
Yeah, it's not on the diagram yet. It would be another thing saying the velocity was measured to be this, and this objects to the claim, this claim, which is made right now independently of measurement. It's like, oh yeah, I think the velocity is, I'm just thinking that without justification. It can be justified by a measurement, it can be justified by a formula, it can be opposed through a formula, true. Yeah. But you're right, it can be, and that would be a separate thing. Oh, this measurement thing gave this reading.
So what I'm saying is you cannot falsify anything without observation. You always have to have observation. Otherwise, you cannot falsify. You say my formula is better, your formula is better. It will never end. But let's test it. And you always. I think the only way to falsify thing is by observation, unless you are doing mathematics, which is logic.
Mathematics, philosophy. There's a
theoretical
huge amount
physics.
of.
And
there's a huge amount of discourse that is not based on that is not empirical.
Yeah, but I'm thinking day to day, the thing that we are using, you always have to use observation, some kind
My
of.
My day to day is math.
yeah.
Sorry.
Right.
Yeah, I have a philosophy lecture about math, but this is another day.
Yeah, but no, I mean, economics or any sort of social
economics
theories.
Absolutely doesn't use empirical facts. It's well known.
They use you have to debate about models when you're predicting the future and that sort of thing. You do have debates about the actual equation.
But by the way, why did God create economists? So the materialists wouldn't feel so bad.
What I'm saying is that you have to check your theories. The only way to check it is with
math or philosophy. Sorry, it's still in realm for me.
I don't want to go.
The world does not stop at empiricism.
No.
Period.
Yeah.
But okay. So, by the way, would you agree with me that 2 + 2 is 4?
Depends on which system you're using.
Okay, yeah, but if I use
depends on your axioms.
But yeah, in common use,
not in chemistry. Not in chemistry.
Yeah.
1 mole of something plus 1 mole of something else equals 1 mole of something new.
So if we'll take logic outside the issue because those are, let's say.
Yeah, but I won't take logic outside. I won't take math outside. I won't take philosophy outside.
Yeah, but
end of that discussion. Sorry.
Let him make the point.
Yeah. Okay. So what I'm saying about, I can argue about philosophy, but it will take months and years and even decades. Okay.
Yeah, and it's not an empirical discussion, and it's an interesting discussion.
And I'll assume that empiricism has some logical rules at the base.
Oh yeah, empiricism is in scope too. I'm just saying it's not the only scope.
And if we are going to talk, and our scope is public debate, because this is what we're doing.
Yeah.
And in public debate, the only way I know of to falsify claims is by observation, or because
That eliminates any policy decision whatsoever.
can you
You are
explain?
not
Can you
going to be able to use a tool to make any policy decisions, because if you can only decide the point after the event happens, you cannot plan. You need to be able to predict the result of your policy in order to choose a policy before you enact it.
And
let's say
policy
we want to
decisions are
end
based on a
poverty.
combination of predictions, which can be falsified, and values, which cannot.
Just a minute. I want to give an example. Let's say we want to end poverty. Okay.
But that's a goal. That's not empirical. Goals are not empirical.
No. I want to have a policy, like Tim say. I want to end poverty.
Yes.
Okay.
Yeah.
And Tim may have one theory of how to end poverty. Stephen will have one. Each of one will have its own. No, you don't have any theory about that. Let's say that you have. Okay. But in order to establish it, in order to corroborate it, you have to say, okay, look at this country. When they did this theory, they went according to the theory. They were able to reduce poverty, for instance. So in order to do the future, you want to have observation. This is how science works.
But you're placing yourself after the goal has been defined. Most conversations are disagreeing on the goals or the priority between different goals. And that is not an empirical conversation. That is a purely a value conversation. Once you've done that, yes, you're in the empirical realm. But so much of public discourse is pre-empirical in the goal definition. When you say abolish poverty, that's a goal. That's a goal. I mean, most of the public discourse difficulties are before that goal is prioritized.
Maybe we want to do other thing, you say. and you say we want to do this.
And again, let's be clear, empirical is in scope, but I'm saying it's not the end of the scope. It's yeah.
So I'm going back to our scope. Okay, we're doing something very simple. I don't want to get complex, but to say, okay, we want to discuss which formula is better, right? F1 or F2?
Yeah.
Okay. You have, if I'm going from empiricism, I say, okay, to check which one, I can debate with you, but it will be according to observation. Okay, or I don't know. And can you show me any other way to say F1 or F2 is not correct, or one of them is better without empiricism, without observation?
It is what will happen in this case. And I'm not saying, I agree, this is a case for empiricism, but it's possible we don't have access to the measurement. So in this case, what we're doing is debating F1 versus F2 based on other measurement in other cases. Those have been derived from a long empirical history. And I agree, this is an empirical case, don't get me wrong. It's entirely possible that in this particular circumstance, we don't have some measurements. And so we have to make deductions from principle. And this is not an inductive process, it's a deductive process. We've already had empiricism that gives us formula, and now we're trying to decide on a deductive basis which formula to apply to those elements that we know, given those that we don't know.
Okay, cool. But eventually we'll have to test it, eventually. Otherwise we cannot.
Right, but the question is how to model it before then.
Yeah, that's also valid.
So, yeah.
But I agree. I mean, the resolution of this is probably depends on getting measurements eventually. That's the fact in this case.
Yeah, and I say you can build it in many ways, but compound claims, atomic claims, and check every one of them, and check a lot of them. But I think that everything should be, or in this case, everything should be tested empirically at the end. Even maybe your deduction were false. Okay.
Yes, so, possible. Yes.
So if Timothy, if you can tell me, okay, where I'm wrong, okay, where, or maybe your point of view, which I couldn't understand. Anthony,
I think you're focusing on the end result of the one specific debate getting the right answer, and what I'm focusing on is how to model the discussion about what kind of this is how to model evidence brought through mathematics, essentially.
Okay.
And
Yeah,
so the question is, like the question is, should this function be embedded in the conclusion in the top? Maybe, well, can you drag the f equals into there just to see maybe, like no, up into the top, because it's
actually I would put this, I thought it was in this, really. It's this.
Well, okay, that is the point. I think that is the point, right?
And this supports, oh God. Yeah, that'll do. This is kind of, I called it autoclaim here, and I'm not sure you agree. Maybe it's not automatic, but the notion is this is incontrovertible. Like applying this to that, that cannot be argued, and it's not a claim. It's a functional result, but it supports this claim, which is, you know,
right. But
and
but
that can
do you
be
need
argued
that?
with.
Wait. Here's the question then. Do you need that one above?
Yes, because the one above is arguable. Like that this derives from this is not, but this is arguable.
So but in this case, you're not embedding the function inside the claim.
It's true. I'm not embedding this in here precisely because this link is inarguable and this link is arguable. Do you disagree with what I'm saying, that this is arguable and this being related to that isn't?
If it's not arguable, then why model it as a support? Why not just embed it in the claim? And where does the Bob and Ann push the button?
One second.
Yeah.
When you're saying why model it as a support, there's a support from.
It's a derived claim, basically.
It's a derived claim. It is, what is arguable is that this applies. Like this is the applicability is arguable, but so there is a support. Like from this and this and this and this, we support this. And it's true that there is a kind of inarguable component that these combines in this way, but the conclusion is arguable. That is arguable. Do we agree that this is arguable, Tim? That's really important.
Sure. Absolutely. Good. In fact, you can derive that with multiple equations if they all come out to the same number, right?
That's correct. Okay, good. So that's clear. So the question is, where is the support in there? I'm saying there is a support object which is composed of this, and the function machinery. And the function machinery is not a claim, but all of those are claims, and the support is between those four, the function machinery, and the conclusion. Let me put it this way. I don't know,
but then you're getting back to my original point, which was that in this case, you don't argue against that. There is no claim here for the function.
I agree. The function machinery is not a claim. I said that explicitly. It's not a claim. It cannot be argued with. It's part of the support, but it's not a claim. It's inarguable. I agree. The function machinery is inarguable.
Yeah, so this goes back to the function machinery.
Wouldn't you argue against it because it's a support, it's part of the support machinery? Wouldn't you like say, for example, opposing the support, the function is not relevant in this context or something like that?
Which is exactly this claim. I put it explicitly. F2 is applicable is part of. I made that.
Okay,
that's arguable.
Yeah.
That's arguable. That's fine.
So then in this structure, we're back to what I called compound premise.
No, okay. That's an interesting point. Thank you, Tim, for bringing that up because I was confused about this. Okay, let's draw the claim. And basically what happens is kind of, can I make this, send it to the back? Thank you. And let's actually have two of these. Send to back. So we'd have, let me put this in here. So this would be the compound, okay? And there's another compound. Let me.
I'm a little uncomfortable with putting those in the box just because they are claims of their own right, right? They stand alone. So
yeah, they stand alone.
You're grouping them. Yeah, okay.
Send to back. And can I have transparent stuff?
Yeah, remove the fill.
Exactly. Okay, so these are the compounds, and then this compound is the support of this. Sorry, is the premise of this support, right? And this support happens to be a formalized subclass. What is this again? Sorry. No, I don't need this. So what? Oh, I see.
Yeah, the thing itself
got it.
is.
How can I? No, I don't want to rotate it. I want to move it. No, to resize it. How do I resize it?
Click it again, then it toggles from rotation to.
Okay, I think this is good. Okay. And really, I want a single arrow from this to that because it's considered a single premise here. But this is, if it were an informal, so let me actually draw that arrow because that's important. So there's a arrow from.
Yeah, now you can drag the arrow. Stand on the arrow and drag it.
Yeah, I had to.
No, you have to select an arrow on the left side.
I see. From here to there. Right. Yes, that's actually to this. Yes. Okay, that's good. So that's this compound is the premise of this support. This support happens to, it could be stated just as text. Given all of these conditions, the velocity would be 48 meters per second. So that could be text in Stephen's non-formal version. But because we're allowing the level two has this machinery that says, well, the result is incontrovertibly 48. And this becomes the support of this independent claim. The velocity is 48.
Right.
That makes.
And that's more or less what I was proposing before. What I guess is interesting is that the Ann and Bob example doesn't need all of this because essentially there is no alternative function for Ann and Bob.
Okay, now let's do Ann and
Bob. Just before you move from to Ann and Bob, I want to say that I'm looking at everything is okay. I'm just thinking that two things I cannot agree with. One is object 2, the arrow at the top, because this says that they are not inline. Okay, one, and the other thing is I think it's missing is the observation, and let's stress it because this is part of our discussion. So I'll add one box which will be observation of skydiver was 50 miles per meter per second after 10 seconds. So this, yeah. So and then you can say this refutes the F1 and corroborate F2. Let's say 48 meter per second.
Okay, so That I have no problem with adding those arrows. This subjects to this supports
This
this.
supports, yeah, and reject and
That I have no
falsify
problem
the
with
other one.
that. It's for us.
Sure.
It was out of this discussion, but it's perfectly it's perfectly valid. Now I don't understand, however, why you want to reject the other one. That is mysterious to me.
The
What's your
object
problem
to-
with the object to?
Because it doesn't object. It says
You don't actually need it there because
Yeah,
by
yeah.
proving the alternative, it automatically refutes the other
yeah,
one. 'cause
that's
the
right.
One
Yeah.
objects to the other. Yeah.
No. But this is a mutually exclusive.
Yeah, so you can say mutually exclusive, but not objective.
Right now, we're using object two as a special mutually exclusive as a special case of object two. For us, object two is a kind of the generic category, and then we have mutually exclusive as a
I will
special
go
case of
with you.
that.
As long as you put the skydiver velocity was observed,
Yeah.
I will go with you.
We're touching the definition of support.
Yeah, that's right. That's right. For me,
I've no problem with saying this happens to be a special case of objects two.
So delete the objects to from skydiver to the other one because you don't need it.
This one?
No,
No.
Yeah,
That is objects to. It's not mutual.
it's falsified.
No.
It's,
Delete
It's
delete it
empirical-
because
it's
it does
no.
it through
No, that's
the
fine.
other.
It's
Yeah.
empirical proof against a certain claim.
Yeah, but that's the point of the mutually exclusive.
I'm saying one is a mutual exclusive, the
structure.
other isn't. The other is evidence. It's not the same.
No.
Precisely.
But you're perhaps missing the point of the mutually exclusive relationship. In a
I
mutually
see what
exclusive relationship,
I see
if
what
any
you're
one of them
saying,
is
yes.
true, it refutes by itself all the others. So all you
Okay,
need to do
that's
is
fair.
prove
Okay,
one true.
got it,
That's
got it, got it.
Right.
Got it. Okay, I accept that.
why doesn't it? So I say logically, it's if this is right, so the other one is not right. This is what you said, Timothy. Right.
Yeah.
Right.
Okay. Cool.
This is
And yes, Stephen, we know
legible,
this is a layer 2 thing. In the base layer, it could go
this
all
could
over
be
the place.
text in the base layer, and I think
as
we'll
people
get.
enter it.
Like a huge page.
Well,
Yeah.
it's as people enter it, I think, is the point of the base layer.
Now let's do Bob and Ann. I think, hey, we're converging on this one, which I think is a great.
Yeah,
result.
the thing is, I think you maybe by looking at Bob and Ann, you'll see that some of the confusion perhaps came from this case, this special case of Bob and Ann.
Yeah, because for me, Bob and Ann is very different that way.
Okay, for me, interesting. For me, it's very similar because I think the Bob and Ann press the button is the formula.
It is the
Yeah,
formula,
it's the
but
formula.
you
it's
have a
also
similar-
Okay,
Similar case.
but the claim that it generates is identical. That's why it's similar, because you're not going to have an alternative formula for Bob and Ann. There is no alternative to an and.
there's actually, amusingly, Bob and Ann press the button is ambiguous. It could mean they both did it or the team did it. Just for the record.
But disambiguating.
but that's not my point. My real point
Yeah.
is I see a difference between those two because here we have the calculation and the support, whereas in the Bob and Ann, there's no support. It's pure interpretation. It's one claim and another claim,
And yet you can disagree with it.
and yet you can disagree with it, which is
Should we
always true.
should we make a diagram?
Yeah, let's
talk
talk
about
about
Isn't
it.
the anything else that would be the difference in the function where you see no difference in the and, Timothy, like the air resistance in this formula? It would be like in this case, the thing that the whole mechanism works the way it does, that they both have to press the button. Is it not similar to the air resistance in this function?
No, because in the air resistance thing, you've got two competing outcomes, right? You've got like the result is 48 meters per second, and you've got 40, whatever. You've got two different outcomes. And yet you can still debate about two different formula that give the same outcome. right? I could have one that's, I can't even conceive of one in this case, but you could have other formula that come with the same outcome. You're right that if it's, if you have a claim that's Bob and Ann press the button and the mechanism is working, that's an alternative formula. You're right about that. And that would produce an alternative claim. And the two claims wouldn't be mutually exclusive. One is a subset of the other one in this case.
Yeah, I think it's implicit. It's implicit case before you elaborate it. And the mechanism works. I mean.
Yeah, but the thing is, in the case of Bob and Ann both press the button versus Bob and Ann both press the button and the mechanism was working. Like you can disagree with the outcome of Bob and Ann both press the button. Even though I don't know how to, I don't know how to explain exactly what I'm thinking, but let's see if the example helps.
Well, I'll remove component because they're all components.
How they are different, I couldn't understand.
Coming. Or rather, in this case. So this one would be the, I would call, it's the layer 1 compound. It's saying Bob and Ann both press the button. It has two, trying to find the right word here, but two
elements.
Contributing claims. Let me put it this way. So these are contributing, those two both contribute to this, and the machine doesn't know why, how. Of course, a human can read it and understand. But if we formalize, this is a conjunction. We tell the computer, okay, this is a conjunction of the two atoms below. And it's a logical formula, and it's and there's a separate claim. The formalization here, what's interesting is it's a claim. It's saying this human sentence can be interpreted as this logical formula. And you can contest the formalization. Oh, you didn't do it right. No, this actually, if I remove the both and I said, there's two interpretation in this one, it could be the team, which would be something else, right? And have a different interpretation. And they would be mutually exclusive. I'm actually tempted to do this. And here I'm doing it informally. The team by Bob and Ann. Press the button.
But here in this case, we can also have the equation and have a claim, oh, this is the right equation to apply and stuff like that. Exactly as in the other example.
Exactly.
Right?
What I'm saying is this formalization here is both of those are claims. Like interpretation is a claim. I'm saying there's a thing called interpretation. I'll give it a different color. That goes from this to there, and there's another interpretation. And then I can remove that arrow that goes from this to there. And those two interpretations are mutually exclusive.
Why? I don't see how it's mutually exclusive, because Bob and Anna are a team.
Because the team formed by Bob and Ann, you could see that as being true if Bob pressed the button twice. And that would make that claim true, and yet Bob press a button and Ann press a button would be false.
Again. Sorry.
Definitely different.
Sorry, can you repeat that? Okay, so you said that
the team formed, one true outcome of the team formed by Bob and Ann collectively pressed the button. It could be that Bob pressed the button twice. He pressed the two buttons.
Formed by collectively.
It says or even, just Bob pressed the button. Just Bob pressed the button.
No,
it says team, collectively.
Well, that's what I mean. Okay, we're differing on the interpretation of collectively. For me, collectively is the team did it. That doesn't mean they all did it. The team as a collective did it. Okay, it doesn't mean they all participated. That's what I understand by is to be the meaning of collectively. Seen as a whole.
Yeah, it's another interpretation, another layer of interpretation. What is collectively? Because
I think we've kind of strayed from the point of the formula discussion here.
Yeah,
because we only really care, I think, about for that discussion the one on the right. That is an and, right?
Yeah, but
yes.
I wanted to make the point that the interpretation was a claim. It's not a support. It's a different object. It's a claim of interpretation. Yeah.
I'm not ready to go down that rabbit hole. That's a totally different rabbit hole.
It's a very deep rabbit hole. Very deep.
Yeah.
But I think we can. Okay, let's postpone that discussion. I'm happy to postpone it. But I think we agreed that there's an informal compound. Layer 1 compound, and we could replace it, or we can argue about it, or we can do all kinds of things. And this is the formal compound, which is a bit the equivalent of the formula. Where was it? The formula we have here. It's saying you cannot. You can disagree with this as a whole, but it's kind of tied to the components. In that way, it's a logical formula. There are consequences. Like if you cannot consistently agree with the two premises and disagree with the conclusion. That's part of the structure of this one, which is not necessarily true here. You need a human to understand that it's contradictory to agree with both the premise and disagree with the conclusion. Here, the notion is the machine is able to detect an inconsistency in that case because it's being formalized that way.
How does it detect the inconsistency again?
Like the structure of this has, I see this is a conjunction. So it's a conjunction made of those two things. So the relationship is different. It's such that it's supposed to be a conjunction. Here, this and means this is a mathematical formula. It's a logical formula. And that means the machine understands what the and means in this case, as opposed
showing inconsistency to a user. Like if he disagrees with and press the button, and he also disagrees with Bob press the button, but he agrees with Bob press the button and press the button, that's like inconsistent.
Okay.
Yeah.
That's yeah.
The machine
I hope the machine can really show it, but we understand that it's possible. And okay.
Whereas in this case, this is the informal layer, the base informal layer. Like you could say, oh, I believe this, but not those two. And the machine would go, okay. Because I don't know what is the relationship between the components and the compound. That's an opaque compound claim. I know the components are important to the compound, but I don't know how. That's an opaque compound claim. And this is a formal compound claim, which means that the machines know how the truth value of the atoms relate to the truth value of the compound. And that's what makes it a formal compound claim. And I'm happy to see Stephen nodding because I was hoping to channel him well here.
Yeah, I'm actually thinking, well, we don't have to go into that now. But I was thinking of the base layer, calling it like a claim canonical layer and layer 2 like an argument canonical layer or something like that. Because that is what it is. The base layer would focus on single representation of claims, whereas the layer 2 or whatever, if we want to draw the distinction, is more like canonical arguments, arguments being maybe functions or more elaborate forms of canonicality. But that's a separate discussion. But yeah, I agree with most of what you said, Martin.
Well,
it's
as
more
I
of
said,
do we
I
agree where
was
it
trying
goes.
to
But
channel you. I'm happy to know I did it successfully. Tim?
I just want to know then, how are we modeling this given the function structure? I think that, like, if we can come to a conclusion on this, we've finished that discussion and we can move on, I think.
Yeah, mapping indeed is the key open discussion here. Like, how is there mapping? What goes where? Is it a two-way mapping or one-way mapping? I think that's still a bit undefined.
Well,
is it going to be the A and
this
B
is why I
equals
introduced
C
this, yes.
structure? No. No.
No.
I think it's undefined, and that's why it's
why did you not introduce that for the other one? Why did you not introduce that for F equals MA?
Because F equals MA is not an interpretation. Okay, it could be. Okay, I could introduce it. Let me introduce it. I'm saying as such, it's not an interpretation.
No. Don't.
Let me do it with. Let me do it.
The structure we had.
No. Let me do it as an interpretation. I think that's perfectly valid.
I guess it would be a different way of reading math or something. If there's opposing math interpretations, and it'll define which one it is or something along those lines. But yes, I agree. If it's in one, it should also be in the other. I don't see a difference. But isn't this the whole ambiguity of any claim? And then there will always be ambiguity.
Yes, there will be always. Interpretation is something every one of us has another interpretation to the same sentence sometimes.
So here it's the text form of this claim. And should be 48.
That even includes the formula in the text, right? Basically.
Yeah, you're right. And I have to include, by the way, F2 is applicable.
But is that what we're talking about right now? It's just like you wanted to extend the diagram, Market One, right?
Yeah. Applying
I think what Tim asked was like, how do we put the formula into the other diagram?
Yeah, we just created a language here to express this. I just wanted you to apply this language to the other situation instead of introducing new language. I don't understand why you're introducing new language.
What do you mean new language? What I'm saying is this is the language form. And okay, you asked me, okay, because you asked me, can you use the interpretation thing here? And I said, yes, absolutely. There's the notion that—
No, I don't want you to use the interpret. I want you to do the following. Create a little function box and call it A and B. Draw a line to Ann press the button and Bob press the button. Make it automatically generate a claim and have it support that claim.
Yeah, because the arrows between Bob press the button and your compound, like what is that arrow? What does it mean?
This is kind of what's in there, right? This is the formal.
No, if you're saying equals C, this means that, and this triggered the missiles. So
yeah, okay.
No, it would be.
I'll remove the C.
It's true. It's just A and B. Yeah.
No, fine. No problem with that. And it goes at this formula level. Okay.
Be careful with the missiles. Yeah.
And then the claim, Bob press the button and Ann press the button, is a separate standalone claim that can be auto-generated by the A and B.
Yes,
Right.
correct.
So there, that's what I mean by using the same modeling language to repeat it in here.
Actually, I would
And then
use
you
a-
can still,
I would use a symbolic and just to emphasize that this is machine, not human.
okay.
This for me, this was already the mathematical thing. That for me, that was the mathematical thing. This is why I didn't bother, because maybe what I should have done is make that one
Yeah,
deeper
but
purple.
the arrows pointing to it, like what's the interpretation of these arrows?
Yeah, you're right. That's important. That's the component of conjunction. Actually, it's not, you know, it's not the arrows that are, and maybe I should reverse the arrows. I'm thinking about it.
Why don't you use the same scheme or notation that you use in the other? Why use a different notation
Right.
here if it's the same thing? I think that's if you're defining a language to express, it's just reuse the same language.
I don't see myself as using a different language. I don't understand
like
what your
colored
problem
box
is.
that's not present in the other one. Yes. Okay.
Yeah.
What box is present here and not in the other one?
Yeah, well, before the A and B blue one with the, I actually don't even know what the box is. But yeah,
well,
the F2 one.
see, I was not comfortable with this box. I would not have added it.
Okay, so then it's not the same.
It is the same. Well, it is not the same because this one second. This one is a support. This one is a claim. So there is a difference. Here we have the formula inside a claim instead of inside a support.
And this is the point I was trying to get at, is this is where, because the claim is constructed out of the formula, it's one and the same. The claim itself is an expression of the formula.
Okay.
Right?
Yeah.
The claim is the formula, and yet you can disagree with the result of what the claim is saying in this case. That's the part I'm struggling with is, why can you do it in this case, but not do it in the other case?
That's more intricate language because I think it's the exact same thing.
Okay, that's a good question. You can, okay, good question. Let me think about this, because I'm saying this is incontrovertible, but can you disagree with the support?
You can disagree with the support because you think it's the wrong formula being used. Right?
Yeah, well,
Yeah.
I was putting that in the premises.
I mean, in the velocity case, we have an equation. I think that's different than the other thing on the top right.
But it's true. Maybe that was a mistake. That's a good question. Is this part of the compound, or is it the support of that autoclaim? That's interesting.
I see it as a support. I see it as a support of the autoclaim.
Yeah, let me think about that one. Okay. I'm not convinced, but I'm not against it. So let me take it out for now, just to compare what it means. And then we have supports, and we have the same on the other side.
What do you call it? Supports. What is applicable? What is support?
Support is an argument in favor or against. It's really an argument in favor. Supports means that it is trying to prove the conclusion claim. But I would say it supports. Like I think that the function and the velocity in your box and the arrow that goes to autoclaim is the support. Like I see that.
I don't think support is again, but maybe I'm coming from
Can I remove these
how do you call
arrows?
it?
I think they're distracting. Those were the multi-premise arrows.
I'm coming from an experimental view, so
Yeah.
So support for me is for instance, yeah, we saw the skydiver velocity and it was 48 meters per second, and this was support this supports the velocity of scalar will be
No.
Like
Yeah, but we're not just
evidence, you
saying-
mean?
yeah, evidence-based. I'm coming
Yeah.
from experimental.
Yeah, no, we're using support in a broader sense. We're saying anything that supports a conclusion. It includes logical support, not only like we could call your thing empirical support. I have no
empirical.
problem
I'm
with that.
coming. Yeah,
And that's a
empirical
special
support.
case, but here we're using it more generically.
It doesn't say it follows. From my perspective, it follows that. Okay, so in kind of
It follows is the arrow going the other way.
for instance, if you say F1 equals is V equals A multiple T, and this follows that the velocity of scalar will be falling after 10 seconds will be 90
No,
meters.
but follows is going, it's the arrow going in the other direction. We can't use follows in this direction.
Why? If we have a formula, and
if A supports B, then B follows from A. The sentence order is reversed.
All right, wait. Okay, guys, go up to the upper left-hand corner of this diagram, because I think no upper left-hand. No, all the way outside the frame. Yeah, to the left, there. This is how I more or less was seeing. I don't know if this is exactly. Yeah. Oh, that's a compound, so it's even more complex. But the point being that what I was seeing is that you have your compound premise, which has the formula inside it. It has the set of premises and some formula with a relationship of how the premises work together in this formula. And that works as a premise. This isn't the diagram I was looking for. Maybe I have to draw one.
Maybe you do. There's this one. There's.
Let me see.
Let me reduce.
If I understand correctly, the one time you're talking about.
Oh, wait, there it was. Maybe I'm the.
And I'm talking especially empirically.
Oh, sorry guys, I need to leave, but feel free to continue. I'll watch the video.
No, we can't
Sorry.
continue without you.
Oh, please do.
No, we cannot physically. When you leave, it bounces us out.
No. Last time I pressed the wrong button.
Okay.
You can give one of us to be a host.
Yeah, I can. Okay. Bye, guys.
Bye.
Bye, Felix. Let me.
Before we continue, just
Okay.
so can I remove these arrows because we've agreed to use compound claims?
How would you describe the relationships without arrows?
We have the relationship between the compound and the support. Now, I'm happy if we want to say this should go to the formula. I have no problem, or at least another one to the formula. But it's the idea is we're using the compound. Now, it's possible, okay, maybe it's from the formula we have details. Okay, fair enough. I won't fight. I mean, this is the question I was asking. The formula could have more detailed arrows. Okay, cool. But what we've done here, I mean, I was still hesitating, beginning to like it, because that means that this becomes a claim that can be argued. The support becomes, being a subclass of claim, becomes arguable.
What is applicable? What is applicable? Sorry.
Sorry, I meant arguable. I'm saying there's an unarguable part here, but if we get this out of the compound, that means I can argue against the applicability. Yes, no, I meant applicability. The applicability of F2 and make that the arguing for or against this claim, even though this part, the conclusion of the formula is unarguable. What do you think?
I don't know if exactly applicable.
I think that's what I said originally, right? Like Antoine.
Yeah, I think it is.
Yeah, that's how I looked at it. If you want to do, I mean,
I'm not against that. The proper subset. Yeah, I'm. So here, what I'm realizing is we have kind of two components. There's the kind of level 1 support here, and there's the, oh, no, let me remove that. And there's the autoclaim part is saying this 48 is tied as a formula, an arguable formula application to the content of the claim. And this actually, what I'm realizing is even this, we're kind of assuming that there's a formal version of this. Now this is getting interesting.
Assuming there's a formal version of it? What do you mean?
Let me draw it to be clear.
Sorry.
Oh, right. And then you get into, though, you know, then you get into the problem of, well, how do you pull out the numbers out of a claim, right? If you're using the claims as input into a formula, how do you pull the numbers out of the claim?
And that's a layer 2 thing. And this is about the interpretation. Like this with the 48, you know, addressable. Let me put this at the back so we see what's going on.
I mentioned this before, right? The point is this
Right,
whole
did, yes.
auto-claim logic only works if you already have fully formalized claims.
Absolutely, I agree.
Yes.
Otherwise, it doesn't have a
Yes.
benefit.
Yeah,
So you need the whole posit structure, and it's a huge implementation.
Yeah, so basically same thing. This is an interpretation, this formalized version is an interpretation of that.
So going back up to Bob and Ann.
Yeah.
The question is, do we need a structure where the claim has the formula embedded in it? Or can we use the same structure where we have the A and B, it auto-generates a formal version of that statement, and you could disagree with that formal version?
For me, this is a historical accident. That is, do people first enter a sentence or do they first enter the formal version? The interpretation is saying, oh, the sentence, it could go in either way,
It
right?
could be either. It can go in either way.
Exactly. Right. They could have started with this, and then somebody enters this, and then a third person says, oh, but this is an interpretation of that. So this should be, and this is the thing, if the interpretation is uncontested, then I would say, whenever we see this, we would propose, oh, actually use the formal version because it's supposed to be equivalent. And if you disagree, then contest it. But as long as it stays uncontested, the notion of interpretation is you would show the formal version instead of the informal version.
This is a curation mechanism, right? I mean, it sounds to me like a curation mechanism, because you're suggesting a more formal version as like the correct interpretation of a less formal.
Yes, yes.
And then you're saying if it's uncontested, meaning again.
Yes. Correct.
And I would agree, but it's just very high level for me.
I agree. I agree.
It's like curation on top of layer 2.
Yep. Well, layer 2 doesn't make sense unless we have that curation, frankly. We need to be able to explain that, yeah, this is the correct formalization of that claim. Without it, I don't see how to use layer 2. So I don't think it's above that way. It's part of.
Yes and no. First of all,
it's above in the sense that it's a meta.
A canonical layer 2, definitely. That's I think Yeah, but I think layer 2 by itself can still be useful just to make one argument more formalized, like in one article or whatever.
Yeah.
Like in a federated system, if you will, where you then aggregate all of these formalized arguments and then somehow you need to curate that in. So a canonical layer 2 does not make sense without curation. Yes.
Yes. And whenever I'm writing interpretation here, I do mean that it's a claim because you can contest the interpretation. And you can say, yeah, this interpretation disagrees. Maybe I shouldn't say mutually exclusive, but disagrees with, you know. Because you can have multiple interpretation of an informal claim, and that's the whole point of the informal claim. Okay, I think this is as good a stopping point as any. How do you feel?
Yeah, I agree.
And I suggest for the next meeting to go into the two-way mapping of
Sounds
this thing. I'd love to see what this means, like what goes in the base layer and what goes in the second layer.
Yeah. Yeah, I'll try to have a JSON by, oh God, tomorrow. I'm so busy these days with other stuff, but I'll try to have a new version of the JSON by tomorrow.
Okay, cool. Thank you all.
Yeah.
See you next time.
See you tomorrow.
All right, I guess it's tomorrow. Yeah. All right, guys.
Oh, by the way, I have another meeting. Oh, no, that's okay. It starts. I have a meeting at the hour at tomorrow. At some point they're like, oh, you can come a half hour before. And I thought that was the start of the other meeting. And I'm like, oh, no conflict. But actually it's just come early if you want. No. But I'll have a hard stop.
All right.
Bye.
See you.